Okay, so in this lesson, we're going to look at how to graph exponential functions using transformations. And the transformations we're going to talk about in this lesson is going to be translations, and it will be vertical and horizontal translations. Now, what I mean by translations is this. So remember in a previous lesson, we talked about graphing quadratic functions. So if this right here represents the graph of y equal x squared, so remember the graph of y equal x squared has a vertex at the origin, and remember if x is 1, 1 squared is 1, and so on. So you notice the points are in the proper places. So in terms of translations, what happens is that you can graph variations of this function. You can move the graph to the right, so that's a horizontal translation to the right, or you can move it to the left, that's a horizontal translation to the left. Okay, so when you go right or left, you're looking at horizontal translation. So that's what I mean by horizontal. The other translation is vertical. So I can move this graph up so many units, and I can move it down so many units. So that is what I mean by vertical. So again, with regards to translations, this is horizontal, and this right here would be vertical. Okay, so those are vertical translations. All right, so horizontal translations and vertical translations. Together, those are called transformations. Now, there are other types of transformations, but what we're going to focus on here will just be translations, horizontal, vertical. Okay? All right, now, with regards to what we want to do today in this particular lesson, we're looking at graphing exponential functions using transformations. Now, in a previous lesson, we graphed this exponential function, something looks like this, f of x equal 2 to the x, let's say minus 3. All right, 2 to the x minus 3. And the way we did this in a previous lesson is this. So we first of all looked at the horizontal asymptote. And so remember, all exponential functions have a horizontal asymptote. And so the horizontal asymptote we found for this, the horizontal asymptote, was, remember, horizontal asymptote is a horizontal line, so we got to call it y equal, and it's just this constant right here, so negative 3. And so then what you did, if you recall, was that you graphed the horizontal asymptote using a dotted line. And so let's say this is my horizontal asymptote here, right here. Okay, so that's my horizontal asymptote. So this is y equal negative 3. And so we then, if you recall, what we then did at that point was we used a t-table to just plot a few points. And so if x is 0, remember, a exponential function always has a y-intercept. Because remember, the domain is all real numbers. So the horizontal, an exponential function will always have a y-intercept. So always let x be 0. First thing you would do is let x be 0. So if x is 0, I get y equals, remember f of x means the same thing as y, I get y equals 2 to the 0 minus 3. Well, 2 to the 0 is 1. 1 minus 3 is a negative 2. And so that's what we did. Remember, that was in a previous lesson. So we then plotted the point. We plotted the point 0, negative 2. So when I plot the point 0, negative 2, this is what I get right here. So there's where the graph crosses the y-axis. So then we did a few more points, and so we said, well, if x is 1, I get y equal 2 to the first minus 3. So that's 2 minus 3, which is a negative 1. So then I plotted the point 1, negative 1. And so then I get this point. 1, negative 1 is right here. And then remember, we had to do a few more because remember the graph of an exponential function looks like this. And so then we said, all right, if x is 2, I get y equal 2 squared. if x is 2, y equals 2 squared minus 3. So that's 4 minus 3, which is 1. So then I plotted the point 2, 1. So I get something that looks like this. And then let's do one more. So if x is 3, I get y equals 2 to the third minus 3. So that's 8 minus 3, which is 5. So I plot the point 3, 5. And so when I plot the point 3, 5, I get this. Let's see. I get something that looks like this. And so you know, and when we did this particular lesson a while back, we talked about how to determine if the function's increasing or decreasing based on the base. Remember all that? All right, so we know that this part of the graph rises rapidly, something like this. And then this part gets closer and closer and closer to the horizontal asymptote. And so that was the graph of y equal 2 to the x minus 3. And that was all you did. And you were done. What we want to do in this lesson, though, is this. We want to talk about graphing something like this using the idea of transformations. Using the idea of transformations. All right, so if I'm going to talk about graphing this function without doing what I just did, but using the idea of transformations, I need to use the idea of translations, and I need to talk about what we mean by parent function, a parent function. So we're going to talk about a parent function. Parent function. So whenever you're talking about transformations, you have to also talk about what a parent function is. A parent function. All right, so let's talk about parent functions in relation to exponentials. Okay, so remember when we first talked about the definition of an exponential, the definition of an exponential function looks like this. So it's f of x equal b to the x. That's what we said. Where b was a positive number and b could not equal 1. Okay? So that was the definition of our exponential function. And from there, we did all kinds of other stuff. We graphed things that looked like this. We graphed 2 to the x plus 5, things like that. And the base wasn't just 2. We did other bases. We did base like 1/2 to the x, 1/4 to the x, and so on. Okay, now, I am going to write several functions here with different bases. All right, so here's one of them. And I'm going to just go ahead and use f of x in each case. So f of x equal 4 to the x plus 2. F of x equal 3 to the x minus 1. F of x equal 2 to the x plus 4. F of x equal 5 to the x minus 3. Okay? All right, now I have 4 different functions here. 4 different functions. Each of these functions you're going to see is going to involve a translation. So either I am shifting, see this right here, this right here is y equal, this right here is y equal 2 to the x. So here's y equal 2 to the x right here. So either I'm going to be shifting y equal 2 to the x up, vertical translation, or a horizontal translation. And notice as I do the vertical translation, see how everything moves up or down, even the horizontal asymptote. So you see how it's moving? That's vertical translation. So everything moves with it, the horizontal asymptote and all, and then left and right. Okay? So horizontal translation, vertical translation. Now, when we move this, what we're moving is going to be called the parent function. So this is what we're going to be moving. So when we move up or down, left, right, we're dealing with what's called the parent function. So before we can talk about the parent function, we need to know how to determine what the parent function is. Okay, so parent function. Okay, So the parent function is going to have this form right here. That's the parent function. So whenever you talk about the parent function of an exponential, it's going to be the base raised to the x power. That's your parent function. So let's talk about the parent function here. So over here, the parent function, and I'm going to call the parent function g of x this time. So let me say the parent function is g of x equal, and then the base is 4, and you just say raised to the x. So that's your parent function, 4 to the x. And the reason I use a different name was because this 4 to the x plus 2 was already named f of x, and those are two different graphs. So remember, those are two different graphs because this has y horizontal asymptote of y equal 2, and this has horizontal asymptote of y equals 0, or the x-axis. So you got to name them two different functions. All right, so now that we know what the parent function looks like in terms of an exponential, can you tell me what this parent function is? So parent function, think about it. Parent function, I'm going to call it g of x. So what's the parent function? All right, if you said, remember, it's got to be this form. So your base, which is, and the base here is 3, so you just say 3 to the x. And from this parent function, you'll be able to graph this. From this parent function, you'll be able to graph this using transformations. In this case, translations. So if you look at this one now, you should get the idea. So parent function, first thing you do is determine what the parent function is. Parent function, call it different from f because these are two different graphs. Parent function, g of x equal, what's the base? Well, the base is 2, and you raise it to the x power. Over here, parent function. So you're going to say g of x equal, and this is a 5. What's the base? Well, the base is 5, and you're going to raise it to the x power. So those are your parent functions. So the parent functions for an exponential, it's always the base raised to the x power. 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 Okay, so that's what we mean by parent functions. Okay, now, let's suppose, and we're going to start with a simple example. So let's suppose, okay, so let's go ahead and go back to this function that we did here. Remember when we graphed y equal 2 to the x minus 3? And we did this using what we've learned in a previous lesson. But what I want to do now is talk about how would I graph this, function right here using transformations. All right, so step one is to always determine the parent function first. So let me just think about it this way. So to graph an exponential function using transformations. And remember, in our case, for this particular lesson, we're looking at translations. And remember, translations just means moving the parent function either up, down, right, left. That's all it is. Okay, using transformations. So to graph an exponential function using transformations, we first need to determine the parent function. Okay? And then once we determine the parent function, then we need to graph the parent function. And as we graph the parent function, well, okay, so once we graph the parent function, then you're going to use translation to graph the exponential function. Okay, so as we go through this, it's a very simple process because all we're doing here is just looking at translations. That's all we're doing. So to graph an exponential function, you're going to first of all determine the parent function. Then you're going to graph the parent function. And then you're going to use translation to graph your exponential function. And then you're done. That's all you do. All right? So let's talk about this function here. So remember, we're looking at y equal, I'm going to call it this time f of x. We're looking at f of x equal 2 to the x minus 3. So f of x equal 2 to the x minus 3. Now, based on our discussion a while ago, based on all of this a while ago, based on these four functions and how to determine the parent function, you should now be able to tell me what the parent function is. So the parent function, first thing you do is denote it, is determine what it is. The parent function is g of x equal 2 to the x. That's your parent function. Okay? Now, once you determine the parent function, you're then going to graph the parent function. And so graphing these exponentials are pretty easy to do. So basically, real quick, you're going to do something like this. You're going to, I remember we're looking at this. So from here, you can tell me the horizontal asymptote. So the horizontal asymptote is y equals 0. Okay. In fact, if you look at all these parent functions, all of them, if you look at this parent function, 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 what is a horizontal asymptote? Well, it's all the same. It's the x-axis. Okay, so it's just the x-axis in each case. So you just draw your horizontal asymptote being the x-axis, just like this, and then remember you're looking at this right here, y equal to the x. So then in your mind you're just going to think about a few points. Okay, so if x is 0, and I always use 0. If x is 0, I get 2 to the 0, which is 1. If x is 1, I get 2 to the first, which is 2. If x is 2, I get 2 squared, which is 4. If x is 3, I get 3 squared, which is, 2 cubed, rather. 2 cubed, which is 8. And so then you just plot those points, and you have your graph real quick. So 0, 1, okay, 0, 1, 1, 2, 2, 4, and 3, 8. And then what you did before in the previous lesson was you just, and this was on one of your tests, graphing these, that's what you get. Okay? All right. Now, what I did was I went ahead and I drew this on a transparency, so that way we can talk about this in terms of the translations. All right. So here's y equal 2 to the x on the transparency. See it? Okay. This is it. So then I'm gonna go back to I'm gonna go back to this right here that we did earlier. All right. Now, here is y equal 2 to the x right here. Okay, this is right here. So this is, I'm trying to align it where it should be, right here. Okay, so this is y equal to the x. Oops. All right, y equal to the x, and this right here is y equal to the x minus 3. Now, this I want you to compare. So remember, we're talking about moving up, down, left, right. So here is y equal to the x. To get this graph, what do you think I need to do to the parent function to get this graph? Remember, you're moving the parent function only. So if I move the parent function, do I move it up, down, left, or right? So I'm going to go back and put it where it was. So here is the graph. So to get to this graph, do you see I have to move down? And I want you to notice something. Okay, as I'm moving down, focus on this point right here for right now. As I'm moving down, I want you to count the number of units that it takes for this point to get to that, to this graph, for these two graphs to align. Okay, so but focus on this. 1, 2, 3. You see, they align, right? So listen carefully. So I'm going back. So in terms, remember, is this a horizontal translation or a vertical translation? This is a vertical translation because you're going up or down. All right, so here's the parent function. Here's a graph of the parent function. So I'm graphing the parent function. And then to graph this, notice what happens. I'm going focus on this point. You can even focus on this point. In fact, I want you to look at both of these. Look at these points. I'm going down 1 unit. See right here where it is now? I'm going down 2 units. And I'm going down 3 units. So here is the parent function. To graph this, I have to translate. I have to vertically translate down how many units? 3 units. Now, in my function I want to graph, do you see I'm going down 3? So do you see a -3 located anywhere? If you said here, that's correct. So here's the idea. You see this right here? That's your parent function. Whenever you have a vertical translation either going up or down, the number on the outside will indicate the vertical translation. The number on the outside indicates the vertical translation. It is the same number. It is the same number you use to determine the horizontal asymptote. So the horizontal asymptote here was y equal -3, so that's your vertical translation. You see how before my parent function, the horizontal asymptote was the x-axis? Now my horizontal asymptote is y equal -3, so that means I got to move. Now notice the horizontal asymptote is moving down 1 unit, 2 units, 3 units, and then overlaps. Okay? All right. So now, listen carefully how you're going to write this. Okay. So let's go back to this right here. All right. So I wanted to graph this function here. To graph this function here, the first thing I needed to do was determine the parent function. So the parent function is g of x. You got to use a different name though, because those are 2 different graphs. You saw those are 2 different graphs. Here's the graph of the function 2 to the x, and then this is 2 to the x minus 3. Notice they're different graphs. They're located in different places in the coordinate plane. They have the same shape, but they're in the coordinate plane in different places. Okay. So let's go back over here now. So once you determine this, or once you want to graph this, you got to first of all determine the parent function. So here's the parent function. Then you're going to graph the parent function. Okay, real easily. Graph the parent function. So this is a parent function. So you're going to say my parent function is g of x. Let me go ahead and do it this way. G of x equal 2 to the x. So that's your parent function. So if you want to graph this now, see this -3? So that's going to be a vertical translation. You're either going to go up or down. Since it's negative, you're going to go down. If this were +3, remember that would imply that the horizontal asymptote is y equal 3. You would go up 3. Okay? So listen to what I'm about to say. So we graphed it. First thing you do is going to graph. You're going to graph. Now you're going to graph this. Okay, so listen carefully. You're going to say this. So you're going to translate the parent function, which is this, g of x equal 2 to the x, down 3 units. You're going to translate g of x equal 2 to the x down 3 units. It is down 3 units because of this number right here. Okay? So remember when we did this, every point is shifted down 3 units, the horizontal asymptote as well. So what I would then do is this. I would go ahead and move, first of all, the horizontal asymptote down 3 units. So instead of here, you can go down 1, 2, 3. So here's my horizontal asymptote. Okay? First thing you do. Then you're going to take each point. See those 4 points they did earlier? You're going to move those down 3 units. So 1, 2, 3. 1, 2, 3. See what I'm doing? 1, 2, 3. 1, 2, 3. And now all you do, I'm going to use a different color. And so now all you do is draw your exponential function. So that's what we get. Try and do the best I can here. all right, and goes towards the horizontal asymptote. Okay, so that what I just graphed, this right here, is f of x equal 2 to the x minus 3. So f of x equal 2 to the x minus 3. And again, here's the transparency. Okay, watch what happens. See, there's the graph right here of y equal 2 to the x. I'm shifting it down 3 units. 1, 2, 3, and I get this. Okay? All right, so listen carefully. If I wanted to graph h of x equal 2 to the x plus, let's say, 4. H of x equal 2 to the x plus 4. All right, so in your mind, you know what that plus 4 indicates. That plus 4 indicates the horizontal asymptote, y equal 4. So you know that the first thing you do is you're going to denote the parent function. So the parent function is h of x. Oh, sorry, you have to use a different function. So I'm going to use the same one here, g of x. Parent function is g of x equal to the x. So first thing you do is you graph the parent function. See, it's already graphed. All right. First thing you do is graph it. So it's already graphed. All right. Now, then you're gonna use the idea of translation. So we're trying to graph this. So think about that plus 4, your horizontal asymptote. So remember what that means. That means I'm going to take this horizontal asymptote and I'm going to shift it, since it's plus 4, I'm going to shift it up 4. You're going to shift it up 4. So then you get this right here. Okay, and every point on 2 to the x, you're going to move up 4 units. 1, 2, 3, 4. Look what's happening. Look what I'm doing. 1, 2, 3, 4. 1, 2, 3, 4. Right here. 1, 2, 3, 4. And so when you graph this, let me use a different color. Let's use purple. So if I graph this one now, actually that's what happens. I get something that looks like this. Okay? And so that right here would be h of x equal 2 to the x, h of x equal 2 to the x plus 4. So notice in all cases, the first thing we did was we graphed the parent function. Parent function first, okay? So parent function in this case was 2 to the x. That's right here. Parent function first. And then from there, since it was y equal f of x equal 2 to the x minus 3, I took the parent function, minus 3, and every point I shifted down 3 units, even the horizontal asymptote. Okay, the next one, let's go back here to graph h of x equal 2 to the x plus 4. Parent function is 2 to the x, which is this right here. And then everything is moved up 4 units. 1, 2, 3, 4. Okay? All right, so that's all you do. Now that's vertical translation, all right? That's vertical translation. Okay, let's talk about horizontal translation. All right, so I want to be clear on something now. Vertical translation, if there's a number on the outside, which is where you get your horizontal asymptote, that's vertical translation. Okay? That's vertical translation. All right, now here's where horizontal translation comes in. All right, so let's look at this. Suppose I want to graph, and let me use this. Suppose you want to graph this function. F of x equal 2 to the x minus 1. 2 to the x minus 1. Now don't confuse this with this. Let's say k of x equal 2 to the x minus 1. Those are two different functions. See this? Here, the exponent is x minus 1. Here, the exponent is just x. All right, so don't confuse those two. Those are two different functions. Notice that here, it's 2 to the x, and then subtract 1. Here, 2 to the x minus 1. Okay? So here, that negative 1 represents a horizontal asymptote. Here, the horizontal asymptote is 0. See that plus 0? Remember, you can write this as 2 to the x minus 1 plus 0. So this right here is your horizontal asymptote, which is the x-axis. All right, so don't confuse those. All right, now let's go back to that vertical translation. So remember, this is a vertical translation. So here's your parent function. You're going to shift it down 1 unit. Okay, shift it down 1 unit. Okay, over here, notice where the negative 1 is located. The negative 1 is locating the exponent. So this is going to be a horizontal translation. Vertical translation, horizontal translation. Vertical translation, horizontal translation. All right. Now, remember, in this lesson, all we're focusing about in this lesson here, because of time constraints, all we're focusing on is one translation, vertical or horizontal. In another lesson, you can combine those. So you can do two translations. So you can do a horizontal translation and then a vertical translation. So you can do two translations at once, meaning this. Now, this is not this lesson, but meaning this. So meaning I can, instead of just going down like this, I could go down and then to the right. I could go up and then to the right. I could go down and then to the left. I could go up and then to the left. So these are different translations. These are multiple translations I can do in one problem. But in our case, we're just doing only one. So either it's going to be vertical translation down, vertical translation up, or it will be a horizontal translation to the right, or horizontal translation to the left. Okay, now let me say this again. This right here, this is what kind of translation? This is a vertical translation. This right here, what kind of translation is this? This is a horizontal translation. Okay? Whenever you're dealing with vertical translation, that's the easy kind. Graphing a vertical translation is the easy kind, because this number right here, as you see it, is what you get. The horizontal asymptote is y equal negative 1. So I take my parent function and shift everything down 1. If this was plus 1, I take the parent function and I shift everything up 1. Okay, so that's the easy kind. A vertical translation, the easy kind. This, for many students, is a little bit harder to see. All right, and here's why. All right, so I'm gonna do this one using a t-table first, just to show you what kind of translation this is. We know it's horizontal. Okay, we do know it's horizontal, but what you don't know yet is this: is it a horizontal to the right or a horizontal to the left? That's what you don't know yet. Okay, and that's the more difficult one for many students. All right, so let's go ahead, and to do this one, we're going to use a t-table. Okay, all right, so and again, always find the y-intercept first. So to find the y-intercept, we're going to let x be 0. So if x is 0, I get 2 to the 0 minus 1, which is 2 to the negative 1. And remember, 2 to the negative 1 means 1/2. If you didn't remember that, then remember to make the exponent positive, make this exponent positive, you take the reciprocal. So well, let me rephrase it. To make this exponent positive, you take the reciprocal of the base, and the base is 2, so it'll be 1/2. So basically what you have is this. You get 1/2 to the first power now, which is just 1/2. So if this was, let's say, 2/3 raised to the negative second, just a review, if you have 2/3 raised to the negative second and you wanted to make this exponent positive, you'd have to take the reciprocal of the base. So that's 3/2 and then squared, which will be 9/4. Okay? But just use your calculator. So when you raise 2 to the negative 1 power, you get 1/2, 0.5 on your calculator. So if x is 1, I get 2 to the first power minus 1, which is 2 to the 0, which we know is 1. So I'll put the point 1, 1. If x is, let's say, 2, I get 2 to the second minus 1, which is 2 to the first, which is 2. If x is 3, I get 2 to the 3 minus 1, which is 2 squared, which is 4. If x is, let's say, 4, I get y equal 2 to the 4 minus 1, which is 2 to the third power, which is 8. Okay? All right, now I am going to graph the parent function first. Okay, so remember, always look at the parent function when graphing transformations. The parent function is 2 to the x. All right, so we already know what that looks like. So I'm going to just go ahead and into a new grid paper, I am going to overlay. So here's what we have. We have this grid paper. So I'm going to overlay without actually having to draw it. I'm just going to overlay the transparency where it should be. So this is the graph of my parent function right here. Okay, that's the graph of my parent function. All right, so remember the horizontal asymptote is on the x-axis. What I want to do now, guys, is I want to graph, what we're interested in, we want to graph this function. Okay? Now you have no, all you know is that this is a horizontal translation. You have no idea yet whether I have to translate the parent function to the right or to the left. All right? So we're going to learn what it is. And so here's what we're going to do first. We're going to plot these points. And so here's the points I get. 0. Let's do 4, 8 first. So 4, 8 is right here. 4, 8. The next one was 3, 4. 3, 4 is right here. The next one was 2, 2. 2, 2 is here. The next one is 1, 1. Oops, sorry. 1, 1. And then 0, 1/2. Okay? Now, remember the horizontal asymptote is the x-axis, so y equals 0. So here's my horizontal asymptote right here. Okay? Here's my horizontal asymptote. And I'm going to graph my exponential function just like this. Okay? And let me just go ahead and write this as, I think we had called it f of x. So f of x, so this is f of x equal to the x minus 1. Okay, now, here's what I want you to see now. This is how you're going to determine whether we're dealing with a horizontal, a horizontal translation to the right or the left. Okay, so remember this right here was the graph of the green one is the graph of my parent function. To get the purple one, do I have to move to the right or the left? To get the purple one, do I have to move to the right or the left? Well, if you said the right, you're correct. All right, now listen carefully. I want you to look at this point, and as we move to the right, I want you to count the number of units I moved. So look, how many units did I move? I'm going to do it again. Look. Now remember, you can't look at the horizontal asymptote because the horizontal asymptote stays the same. They're both the x-axis. So you got to focus on one of these points here. So I'm going to move it to the right. Obviously it's to the right, but how many units? If you said 1, that's true. 1 unit. So 1 unit to the right. 1 unit to the right. So in my exponent, do you see, first of all, do you see a 1? You see a 1 right here. Okay? Now, here's what confuses a student. They see a negative 1. So when they see a negative 1 right here, when they see the subtraction symbol, they always want to go to the left 1 unit. So you see, they want to go to the left 1 unit because it's subtraction. Whenever you do a horizontal translation, it's counterintuitive of what you would think. Counterintuitive. So the best thing to remember is this. Whenever dealing with a horizontal translation, think of x minus and then that number. X minus and then that number. And that number, the positive 1, is your horizontal translation. So you move to the right 1 unit. Okay? All right. Now, if this was y equal 2 to the x plus 1. So let's talk about that. Y equal, let's call it k of x. K of x equal 2 to the x plus 1. All right, so my question to you is this. Is this a horizontal or vertical translation? All right, so if you said horizontal, that's correct. Because remember, this is plus 0. And so your horizontal asymptote is the x-axis. So there's no movement up or down. So there's no vertical translation. So it's just a horizontal. So that's a horizontal translation. So my parent function, so remember the first thing you do is state a parent function. Parent function is g of x equal 2 to the x. Just use a different letter, a different notation than k of x or f of x. All right, there's my parent function. So then you're going to translate g of x equal 2 to the x horizontally. So that's a horizontal translation. Horizontally to the... All right, now, let's go back over here. This was a horizontal translation, but did I go to the left or the right 1 unit? So if you said to the right 1 unit, that was correct. That's what we did. So think counterintuitive. All right, counterintuitive. Think the opposite of what you see. So again, if I think the opposite of what I see, then that means I'm going to move to the left 1 unit. So you're going to translate g of x equal to the x horizontally to the left 1 unit. Okay? All right, so that means this. Okay, so listen carefully. So that means this. So remember this right here was the green. The green was the parent function. So I'm going to move it to the left 1 unit. So see right here? So this point becomes this point. This point becomes this point. This point becomes this point. Okay? So move it to the left 1 unit. And so this is what you get. All right? So what I'm going to do is this. So remember, the first thing you're going to do is you're going to, let's go ahead and do this. So the first thing you do is you're going to graph y equal 2 to the x. So y equal 2 to the x. So this is right here. So you have your horizontal asymptote. Now you're going to graph y equal 2 to the x. That's your parent function. Y equal 2 to the x. So 1, 1. Remember, this is g of x equal 2 to the x. So if x is 0, 2 to 0 is 1. If x is 1, 2 to the first is 2. So 1, 2. If x is 2, 2 squared is 4. If x is 3, 2 cubed is 8. All right, so it's very quick to graph the parent function. It's very quick. All right, so I graph my parent function. This is it. All right, now I want to graph now is this now. Okay, listen carefully. I want to graph this. Well, remember, this is a horizontal translation. There's a 1 here, so I know I need to go 1 unit somewhere. 1 unit to the right or the left. Well, remember, counterintuitive, you can go to the left. 1 unit. So here's what you do. What I would do is this. Okay, so I have my parent function. See these 4 points I just plotted? Move them to the left 1 unit. 1 unit, 1 unit, 1 unit, 1 unit. See what I did? And now just connect them. The horizontal asymptote is the same, so that doesn't move. Just do something like this. Okay? And so this right here is whatever we called it. I think it was k of x. This right here is k of x equal 2 to the x plus 1. Okay? All right. Now, let's do one more with this. So we had a great discussion here. All right, so let's talk about one more problem. All right, now let's go ahead. Okay, so let's suppose you want to graph this function. So let's graph f of x equal 4 to the x plus 2. F of x equal 4 to the x plus 2. Okay, so first of all, what you're going to do is determine the parent function. So what's the parent function? Well, the parent function is 4 to the x. So we're going to call it g of x though. So let's say parent function is g of x equal 4 to the x. That's the first thing you do. Then once you indicate what the parent function is, then the next thing you want to do is to graph it. So let's go ahead and graph the parent function. We're going to graph the parent function. So remember that's 4 to the x. All right, so we'll go ahead and just kind of put that right here. So y equal 4 to the x. Use a t-table. First of all, what's a horizontal asymptote? Well, remember, all these parent functions, all these exponentials, all these parent functions, a horizontal asymptote is the x-axis. So let me just go ahead and draw this. Okay, so there's my horizontal asymptote. All right, now let's remember you always have a y-intercept. So if x is 0, I get y equal 4 to the 0, which is 1. Okay, so I'm going to put the point 0, 1. That's this. If x is 1, I get y equal 4 to the first, which is 4. So 1, 4 is right here. If x is 2, I get y equal 4 squared, which is 16. So 2, 16. So I'm running out of room here. No, let's say 2, 16 is about here. All right. So this is going to be a little bit harder to deal with because of the space that's here. But here is the parent function right here. So just do the best you can. Do the best you can with drawing this. Oops, this is not that good, but do the best you can. Do the best you can. Something like that. Okay? So there's the parent function right here. So this is y equal well, this is g of x. Let's call it g of x. So g of x equals 4 to the x. Okay, so that's your parent function. What I want to do, though, is graph this. All right, so let's talk now about translation. So then you're going to say this. You're going to translate g of x, the parent function. Now, is this a vertical or horizontal translation? So remember, this plus 2 tells you that your horizontal asymptote will be moved up 2 units. All right, so that's y equal 2. So that would be a vertical translation. So you can say translate the parent function, which is g of x equal 4 to the x. So translate vertically up 2 units. Okay, and what that means is this. Okay, all you do is use this right here. So everything's moved up 2 units, even the horizontal asymptote. So the horizontal asymptote, I'm not going to call it green. So that's moved up 2 units. So 1, 2. So here's my new horizontal asymptote. Okay? And then every point that you drew, see those 3 points? Move it up 2 units. This point here, move it up 2 units. 1, 2. This point here, move it up 2 units. 1, 2. This point here, move it up 2 units. 1, 2. And then just do the best you can with connecting those. Let's get something that looks like this. Okay. So again, it's hard to graph this one. It's hard to graph this one because of the space here. All right, so there's the graph. Okay, so this right here represents f of x, which is 4 to the x plus 2. Okay, and that's all you do. That's all you do. All right, let's look at another one. All right, suppose I want to graph this one. All right, and I'm not going to use 40x this time. Let's just use a different number because there's too much space here. I can't get much done with that space that's here. So let's do this. Let's say I want to graph f of x equal 3 to the x plus 2. 3 to the x plus 2. F of x equals 3 to the x plus 2. Okay. So what's the first thing you do? Well, the first thing you do is you find a parent function. So what's a parent function? Well, the parent function is g of x equal, and then the base raised to the x power. That's your parent function. Once you get the parent function, you graph it. All right, so I'm going to graph the parent function. I'm going to use the t-table to help us. So we're going to graph y equals 3 to the x. All right, so I know that the parent function, the horizontal asymptote, is the x-axis. All right, so I draw the horizontal asymptote. Okay, then I'm going to use a t-table and plot a few points. So if x is 0, always use 0. If x is 0, I get y equal 3 to the 0, which is 1. So I plot the point, 0, 1. If x is 1, I get y equal 3 to the first, which is 3. So I plot the point, 1, 3. If x is 2, I get y equal 3 squared, which is 9. Okay, and then I just connect them. Let's see, I get this right here. Do the best you can. All right, remember these are the 3 points I just plotted. All right, so I'm gonna darken it because I'm gonna use those in a little while. Okay, so that's the graph. Remember, this is the graph right here. This is the parent function as g of x equal 3 to the x. All right, now let's talk about translation. All right, so we're going to use this. We're going to move this. We're going to use these 3 points to help us. Okay, next one. Is this a horizontal or a vertical translation? Horizontal, vertical. Remember, if the plus 2 is here, that will be a vertical. But notice where the plus 2 is. It's in the exponent. So this is your exponent right here. All right, and you know, since this is horizontally, all right, so listen carefully. You're going to say translate the parent function horizontally 2 units. All right, now let's talk about 2 units because it's 2 right here. But here's where the confusion is for some people. They don't know whether it's 2 units to the right, 2 units to the left, because if you're not careful, you're going to say it's 2 units to the right because you see a plus 2. But remember, with the horizontal, you got to think counterintuitive. So it's really 2 units to the left because the exponent has to always look like this, x minus a number. So x minus a negative 2 is the same thing as saying x plus 2. So this thing I have boxed in is negative. So you can go to the left 2 units. To the left 2 units. So this is what you do. Take all these 3 points and move it to the left 3 units. The horizontal asymptote stays the same. So to the left, what did I say, 2 units? Okay, 1, 2, 1, 2, 1, 2. And then now all you do is just draw your graph. Looks something like this. Okay, and remember that was the graph. This right here was the graph. F of x equal 3 to the x plus 2. 3 to the x plus 2. And so let's look at this. So remember, everything's being moved to the left 2 units. Okay? All right, so the vertical translations are pretty easy to deal with. It's a horizontal translations that's a little bit more concerning for students. So remember this. Whenever you're looking at horizontal translations, okay, so all these right I'm writing a horizontal involve horizontal translations. I'm just use y. Y equal 2 to the x plus 5. y equal 3 to the x minus 4, y equal 1/2 to the x plus 6, and then y equal 1/3 to the x minus 8. All right, so all those are horizontal translations. Okay, but what I'm trying to get you to understand is this. You have to know whether it's being translated horizontally to the left or the right. Okay, so this right here, this will be, these are horizontal, so you can say horizontally. You're going to take the parent function and shift it horizontally to the, well, let's do it this way, horizontally 5 units to the, all right, so remember the exponent must always be in the form x minus, if you got to think of it this way, think of the form x minus a number. So x plus 5 means x minus a negative 5. So you see, but for the number that's in the box is negative 5, so think to the left 5 units. So 5 units to the left. This will be 4 units horizontally, so this is horizontal translation, but it'll be 4 units. Well, this is already x minus, so this box is a positive 4. 4 units to the right. Over here, this is x plus 6. Well, that becomes x minus a negative 6. So it's horizontal translation, 6 units to the left. And then this is already x minus a positive 8. Positive 8. So this is a horizontal translation. So this is horizontal. 8 units to the right. Okay? All right, so that takes care of the transformations in terms of vertical translations or horizontal translations for exponentials.